So good morning students, this is Rukmani Devi, Professor RMD Engineering College. Now we are going to discuss about the finite state machine. What is meant by finite state machine? It can model behavior of any sequential circuit. Sequential circuit is nothing but it is going to be generate sequence of events. It is useful representation for designing sequential circuits. If you take any application, if you take a lift, how the lift is going to be work, because the lift is going to be move ups and downs. So which floor is needed to carry the people, it's going to be stopped, then it getting down or going up. So this operation can be represented in the form of the state diagram is nothing but a sequential circuit. As with all sequential circuits, output depends on present and past inputs. So it has an effect of past input represented as current state. Okay, so the past inputs are current state, the future inputs are next state, and the next state is going to be depending upon the present state inputs and the past outputs. Okay, here the FSM, it has a inputs. The input is x0 to xn minus 1, xn minus 1. Output is y0 to yn minus 1. So this is the state diagram representation. This is for any applications. First we have to do state diagram representation. Here this is also known as state transition diagram. So this is traverse one edge per clock cycle. That is one movement. It's nothing but for one clock cycle. Here state I, the output value, whether the output is 1 or 0, can be represented inside the state. Okay, this is nothing but the input value. So this is input value, this is the output is represented internally in the state. Okay, so the graphical representation of the states with respect to input and output is nothing but state transition diagram. FSM implementation. So this state diagram is given, how this is going to be implemented. Okay, so the present state and the next state can be done by the use of flip-flop. We have a flip-flop. The flip-flop input is next state. Okay, this output is the present state. Now this next state, depending upon, you have a combinational circuits. This combinational circuit has inputs and the input is present state. The input and the present state. Okay, the input and the present state, depending upon this, it's going to be deliver the next state. This next state is applied to the flip-flop. This next state is given to the combinational logic circuits. This will be delivered as outputs. Okay, the flip-flops form state register depending upon the state, present state, next state. So that can be achieved by use of flip-flops. Number of states is less than or equal to 2 power number of flip-flops. For example, if you have a 3 states, so how many flip-flops you have to need? Okay, 3 state means this is 8 state. 8 state means 2 power 3. 2 power 3 is equal to 8. So 3 flip-flops needed to generate 8 states. Okay, the combinational logic calculates next state and the outputs. FSM implementation by using Mealy machine and the Mealy machine. So the Mealy machine is nothing but there is a state, the output denoted inside the state, the outputs are changed with respect to the input. The input is specified in the outside. Okay, so this is input, this is the state. In the state, the outputs are represented. So this state transition diagram can be represented in the structure. Okay, so So there is a state. State can be transferred in the form of flip-flops. Present state and the next state. So the input given to the configurable logic block, depending upon the present and the next state, it will deliver the outputs. So this is the structure of Mealy machine. The next one we have a Mealy machine. So the Mealy machine is nothing but the inside only the state is specified. So the outer arc is nothing but we are going to represent input and output. At what input, where it will go, whether it is a present state or next state, what the output will be delivered. If both output functions include both present state and the input is called the Mealy machine. So you look at this state diagram transferred into the structure. We have a combinational circuit, inputs and present state. So depending upon the input and the present state, the output is delivered and it will go to the next state. So the next state, the states can be represented in the form of flip-flops. Okay, so this is nothing but Mealy machine. This is nothing but Mealy machine. Now what is state encoding? State encoding is nothing but that's how the states are encoded. So if there is a 4 states, each state have a to be represented as a 2 bits. So 2 power 2, 4. So similarly, if you have a 3 states means 2 power 3, you have 8 states means 2 power 3, 3 bits. Okay, it's equal to 8. So the formula is logarithmic to the number of states. Flip-flops are used to simplify the logic at the cost of more flip-flops. The comparison of Mealy machine and Mealy machine. What is Mealy machine? Output function only of present state. Maybe more states. Synchronous outputs. Input glitches not send at output. One cycle, that is a delay, full cycle of stable output. The Mealy machine is output function of both, that depending upon both present state and input. It may be fewer states. It has asynchronous output, not depending upon this one. If input glitches, so output immediately available. Output may not be stable long enough to be useful. So there will be the setup time. Because there will be the output as you have generated through the combinational logic. So this delay will be occur. So FSM, Mealy and Mealy implementation, it's a review part. Mealy machine, Mealy machine. Input value, states are present. Output value represented internally. Mealy machine, input, output values, state. Okay. So you look at it. Here you have a states. Internally, it may be present state, next state. Combinational logic inputs. Depending upon the states, it will deliver the output. Here, input, it will deliver the output depending upon the present and the next state. How the state transition diagram can be represented as a Mealy machine and the Mealy machine. Now, how the signals is going to be delivered. A given state machine would have both Mealy and Mealy state outputs. Okay, but you need to aware of timing differences between these two types. The output timing behavior of Mealy machine can be achieved in a Mealy machine by registering the Mealy output value. So this can be obtained through the register value. So this is about the simple introduction of Mealy and the Mealy. Thank you.